G'day everyone, it's New Year's Eve. I thought I'd do something completely different. It's been a long time since I've done any pyrotechnics, and I actually gave away a lot of my stuff, so I have very little left. But what I did keep, I kept all of my tooling and some of my chemicals. So I thought, well, it's New Year's, right? What's New Year's without fireworks? So I thought I'd throw together quickly some rockets. What we're going to build is this. This is a black powder core burning rocket. As you can see, it's about 1/4 inch. It's very small, it's relatively harmless, very quick and easy to make. The stick is a kebab stick. It's a standard one that you'd use for dinner or something. It's not particularly long. It's just hot melt glued on, as you can see here. Surprisingly, the focus up. The hot melt glue survives the rapid heating, because it happens fairly quickly. It takes a while for the heat to soak through the case and actually melt the glue. So hot melt glue works fine. You can use tape or whatever you want really to hold it on. Sorry about the lighting in here. The lighting's a bit dodgy, but oh well. We can only use what we've got. Okay, so first of all, tooling. Tooling is super important. As you can see here, this is the mandrel, or the makes the core of the rocket. I got this tooling from Walter Pyrotechnics many years ago. It's stainless steel and aluminium. Cost about $50. I think he still makes it. The center pin is made out of stainless steel for hard wearing. Base is aluminium. It's all nicely turned. It's really beautiful. I love his stuff. I have a lot of his tooling that I bought over the years, and it's extra awesome stuff. So look up Walter Pyro Tooling online. As you can see, here's a rammer. This is also called a drift. This one is got a hole in it. This fits over the pin and consolidates the nozzle in particular. As you can see here, if my camera will cooperate and focus up, damn you. There we go. It produces a convergence and divergence nozzle, which helps the gases escape fast and produce lots of thrust. In all honesty, for a rocket this small, it isn't probably that important, but the tooling is extremely nice and it makes a good professional result. It's important, obviously, that the hole is long enough that you don't squeeze black powder between the tip here and the inside of the rammer and accidentally ignite it. Okay, obligatory safety warnings. Obviously, do not try this at home. Everyone will try this at home, I know, but what can I say? First of all, the real basics. Make sure you've got eye protection. Those face shields that some legislatures have actually mandated that everyone uses when they do pyro, really they're the worst thing out, because they just concentrate the burning gases in front of your face and melt your face off. Personally, goggles are it for me. Clothing, no static generating clothing, and this is black powder. It's not particularly dangerous, and I've got a very small amount of it here. Quantity is the big thing. Do not have large quantities of powder and stars and crap lying around. Eventually you will have an accident. I mean, you've got to assume that. People say it'll never happen to me. Well, it might. If it does, if there's not a lot of stuff around, you'll walk away. If there is a lot of stuff around, you'll be in the morgue. Simple as that. So keep it small, keep it covered, and do it outdoors, ideally, if you can. Today's a bit sunny, and I actually got a bit of radiation yesterday, and I'm a bit worried about sunburning. Otherwise, I'd be doing this outside. Alrighty. So, extra part of the tooling, which is completely optional but incredibly useful, is a ram-through funnel. This funnel, again, Walter Pyro Tools, he made it for me. It's absolutely beautiful piece of machining that he's done. It's aluminium. And it comes with a set of drifts, one solid one for ramming it above the core, and one with a hole in it for ramming the bit where the core is still inside the rocket. I should draw a cross section. I might draw some diagrams in another video and show you how rockets work and why. So these ram through the funnel, as you can see here. This makes it super easy because you don't need to change tools while you're working. So these are the cases that I use. I think I purchased these from PyroTube or someone many years ago. They're quite nice. It's hard paper, hard cardboard. You can also make them out of gum paper tape, or just any kind of paper really, but craft paper is the best. And you can see the tooling fits over the funnel quite nicely. So we have our base, we put our tube over it, like so, and then we proceed to ram increments of first some clay for the nozzle, and then black powder using the pierced ram as pierced drifts until we get beyond the core pin in here. Once we're beyond that, then we can use the solid rammer to go right up to the top. Some people put a bulkhead of clay above that and then drill a hole through it. With small rockets like this is a 1/4 inch, because, well, most things seem to be done using imperial measurements because most people are still in the technical dark ages, but beside the point. 1/4 inch motor, I think it's about 3 or 4 grams when it's charged, and it's about 3-4 kilojoules per gram black powder, so the total energy is quite small. Humans are about 8 megajoules per day. Give you an idea of just how much damage large amounts of pyrotechnics can do. If you can think about how much damage you could do with a sledgehammer in a day, you know, a bucket of black powder has many times more than 8 megajoules, and you could seriously screw up your day and everyone around you's day. So that's why you need to be careful, and why I say small quantities. Here I've got, you know, a tiny amount of black powder. This is it's not 1532. This is closer to 632, 631 black powder, which is more commonly used for rockets. I don't actually remember the precise mixture I used for this one because it's so long ago. My apologies for that. It was made by ball milling it for about an hour just to make it homogeneous. Then I dampened it with about 8% water, and I forced it through a mesh, a normal sieve basically, onto some paper and let it dry. The forcing it through a sieve, as you can see, makes it nice and dry. Little tiny granules that are easy to ram. They pass well through the funnel. Nothing worse than trying to ram a really fluid black powder. When it comes out of the mill, it's like talcum powder. And if you've ever tried to deal with talcum powder, it gets in the air, it floats around, you end up blowing your nose black for a week, etc. Terrible stuff. So if you are going to do this, it is well worth processing your black powder first, just dampening it and granulating it a little bit, just for cleanliness. Just makes your life so much more bearable, basically. Don't need to do it though. It's absolutely optional. Alrighty. That's really all there is to it. The rest is just mechanical, right? You have to sit down with your tooling and do it. So that's coming up on 8 minutes of just waffle. Let's actually build a rocket. Okay, one extra thing is the little spatula-y, spoony things here that I built. This is just a plastic straw glued to the end of a piece of timber. I've got 2 different sizes. One here's got a bit larger, and then I've got a smaller one. These I've set up for this tooling, so this is for the clay, for the initial increment, and this is for the propellant. They're not terribly important. The main thing is that you can't just fill the tube up full of black powder and ram it at once, because it'll crush the tube. You should only go about 1 diameter of the tube per increment at a time. The black powder will compact down as you ram it in there. It's actually quite quick once you've got the tooling. I mean, you could make this tooling yourself if you have a lathe, or if you have, worst case, when I first started out, I made my own tooling, some of it out of timber for the larger diameter stuff. Smaller diameter stuff, metals are really the way to go. Non-sparking metals, always. Again, safety, again. Brass, stainless steel, aluminium. Do not use iron, especially iron against iron. And one thing you've got to be careful of is if you put any additives in your black powder, for example titanium. Titanium is particularly reactive and nasty stuff can happen. It can spark while you're ramming it. It doesn't actually happen that often, to be completely honest, and people out there in the industry will say it's completely safe. Other people will say it's a death sentence, never do it. Reality is probably somewhere in between. As with anything, appropriate safety precautions and your standard chance of living if it ever happens to you. Alrighty. So let's start off with the clay. This is pure bentonite. I didn't bother putting any additives in it. For larger devices in the past I've used wax treated clay, so I dissolve a little bit of candle wax in some petrol or shellite, petroleum ether, something like that, just to distribute it through it, and then I rice it through a sieve in pretty much the same way that I actually powder the propellant. Also you can add grog, which is broken up fired pieces of ceramic, so it's sharp and hard and about 20 mesh-ish kind of sized particles that will, as you ram it into the tube, the clay will expand slightly and it'll bite into the wall so that it keys the nozzle in and it won't get blown out with the gas pressure. This whole thing is all about pressure and containment and direction of the throwing the mass out the back of the rocket as fast and as hard as it can. So obviously the casing must be quite robust, so it doesn't simply explode, because the structure of the rocket with that core in the middle means that there'll be pressure build up and the whole thing will try and expand. And if the hoop stress exceeds the design capabilities of the tube, the thing will blow up, and yeah, you'll have what's called a CATO, or some people call it, what is it, catastrophe at takeoff, or catastrophic failure. There's a whole bunch of different ways of saying my rocket blew up and never got anywhere, and basically turns into a firecracker on a stick. You don't want that to happen, so make the cases nice and strong. And blowing the nozzle isn't such a big deal, except your rocket won't get very high. And if you happen to have a payload like a shell or a bunch of stars on the front of it, you don't want that going off in your face if you happen to be near it. As always, fuses are your friend, right? You should use proper good quality fuses. I'm going to use black match. Black match is just well, it's basically cotton string that's been soaked in black powder mixed with water, a little bit of a binding agent like a starch, or a dextrin is the most common one most people use, which is kind of cooked starch, partially hydrolyzed. That stuff makes it cling to the string, and then it'll burn along. The only problem with black matches, it's not particularly reliable, and it can skip. So if a spark from somewhere down at the end where you light it jumps up to the end where the thing's about to go off, then it'll ignite it at that point, and it'll burn at two places at once, and most of your timing's gone. So proper stuff to use is obviously Visco. You can see there's some in there. Visco's a name actually for the coating on the fuse more than the fuse itself, but it became a genericized trademark. Commercial fuse is all built pretty much the same way. It's bunch of strings on a weaving, it's kind of a loom. Well, it's not really a loom, it's more of a rotary placement machine that spins threads in one direction and then in the other, and then the whole thing goes through a bath of this varnish that contains it. Down the middle is black powder and various combinations thereof, some of it even based on chlorate. Some of the bloody Chinese have been trying to kill people. But good stuff is generally black powder or sulfur-free black powder, or potassium perchlorate and sort of not really H3 but with chlorate, more like H3 with perchlorate and no sulfur. That seems to be quite popular in a lot of matches nowadays. Black powder's fine, but if you're doing it yourself, black match works. You can make it in large quantities, wind it up on essentially a square frame, so you can wind it as you're pulling the cotton through your tub of black powder and water. Anyway, lots of information out there on the net. So one awesome thing about pyrotechnics nowadays, when I was first starting, as a kid, as most kids do, get interested in pyrotechnics, there wasn't a whole lot of information, so I went to the local library. This was pre the internet. At the local library, I got the encyclopedias out, and they were full of all these wonderful, wonderful stuff from Kentish and from people even before Kentish that all talked about using arsenates, mercury, chlorates, all this stuff that will kill you one way or another, evil death mix kind of crap, stuff that you should never never teach people until they've got a bit of a grounding in how to do stuff. Fortunately, I couldn't get access to most of the chemicals, so I managed to live through that phase. Let's hear it for crazy youthful exuberance of trying to make stuff that blows up. Fortunately, I survived that phase, as most people do, and I think I was protected a bit by the lack of access to chemicals. Nowadays, chemical access is probably even more difficult, but fortunately, information access is not. There is so much information out there on the internet about how to do this without killing yourself and how to do it safely. You should really go and look. There's a whole bunch of websites. I'll put some links in the bar below when I post this video about some great places where you can get some resources to do this sensibly. In certain countries, it's even encouraged. Well, tolerated is probably a better word for it. And it's a great hobby, let's face it. It's an engineering and geeky and artistic thing that you can do. It requires use of hand tools, which many things don't nowadays. It's as old as the hills, but it's also right up to date with modern chemical and electrical things, firing to music, all that kind of thing. It's an awesome hobby to have. Alrighty, let's actually build a damn rocket. So, first of all, let's take a measure of this bentonite. And you can see I measured just by putting the stuff down on the bench and basically pushing the spoon into it. This works pretty well for me. For other people, they prefer to have calibrated spoons and there's a whole bunch of different ways you can do it. The main thing is you have repeatable increments so that every time you do it, it'll turn out the same, so you have some reliability in your devices. Alrighty, so bentonite goes in. And we don't need the bentonite anymore, so I'm going to screw the lid on it and put it away. Although bentonite is essentially kitty litter, clay, right? It's completely harmless, it's not going to catch fire or anything. It's always a good idea to get in the habit of putting stuff away once you're done with it. Particularly with propellants, you should always put the lid back on. I know that slows stuff down, but you know, you're not in a factory, you're not making thousands of these things in the Chinese sweatshop, you're making a couple for New Year's Eve. Alrighty, so I'm going to use the short drift that unfortunately isn't the ram-through version, that has the conical nose on it to make the nice nozzle profile. For something this small, you don't even need a particularly big mallet. A couple of taps, I like to pull the drift up, turn it around at least a quarter turn, put it back in. Alright, normally I wouldn't take it apart to show you, but what the heck. I can get the thing to focus up. Come on. Thank you. Alrighty, so I'll just spin this off. I'll probably end up breaking the nozzle and have to redo it, but as you can see, maybe you can't see because the lighting sucks, down inside there is the nozzle. You can see the light through the nozzle. It's constricted it to about half its diameter, maybe a little bit less than that. Traditionally, rockets, the nozzle diameter is about a third of the diameter of the nozzle, so a third clay, a third of a hole and a third more clay on the other side going across the diameter. That's pretty popular and traditional. The core normally goes about 7/10 of the length through the charge, so it leaves a little bit at the top that acts as a fuse for delaying to the garniture on the head of the rocket, whatever payload you put on it. And of course, you can just seal the top with a bulkhead of clay if you just want the rocket. These tiny little rockets actually make really cute motors to carry tiny cameras. They're pretty harmless. They go a couple hundred feet maybe. They can't lift much, but they're fun and simple. Alrighty, so I'm going to put that back together. Give it another whack, because normally you don't disturb the nozzle like that. Alright, so now we get to the serious stuff, actually putting the black powder in. And I'm going to use the pierced ram-through drift. I'm going to cover that. It's an extra safety precaution. Most importantly, make sure that, let's see, I'm going to put that somewhere you can actually see, above the rammer. If the thing was to ignite, in the unlikely event that does happen, the gas pressure is going to blow the drift out. You also don't want to have your hands right around the base of the case where you're ramming, because if it doesn't blow it out, the case is going to split and you probably don't want to lose your fingers. So holding the base of the rammer, a lot of people have a proper ramming block, I don't, for various reasons. Something nice and massy that goes all the way to solid foundations is great, because it just doesn't, it has a huge amount of inertia compared to the mallet and will give you good compression. You want to make sure though, especially, that there's nothing that you care about above the drift. If the drift does get projected out by an explosion or discharge of the device, you don't want to have your forehead above here, because you're going to cop it in the forehead or worse in the eyes. Of course, you're wearing eye protection, so hopefully it's just going to glance off the polycarbonate. But if it doesn't, you want to minimise the damage. The actual amount of gas and stuff released by this is not going to be that bad. It'll be a fairly small fire if it happens, because there isn't a whole lot of propellant in a single device. But if you had other things on your desk, so I'm having a bad example here, having a previously loaded one sitting here for you, but you should really go and make sure you don't have a big stock of crap sitting on your desk, because if you do have a fire and all that goes up, well, it's a bigger fire, right? And kill yourself or burn down the place, whatever. Alright, so that's one charge loaded in there. You just leave the ram on funnel in place. In this case, that's the cool thing about it. You don't have to keep pulling it off, putting it back on again. Another increment of propellant. A little bit of propellant may go up the core of this, so I just give it a gentle tap to make sure anything falls back down into the hole. You keep doing this until you've got above that core. Some rockets, particularly larger rocket toolings, will have multiple different size drifts because the inner core is tapered to a point. So as you get with a narrower part of the core, you want a narrower bore in the end of the drift. That's a pretty common thing that you'll see, and many of the rammers, these ones I've never actually done it to because I like them so much and because I want to keep them for, I've got different length cases, so I don't mark them up. But if you have a specific tooling for a specific case, you can mark your rammers with a little, little file mark or something. You can put tape on them if they're particularly loose fit and mark them with just a pen, and that'll tell you when it's time to change. So once you see that mark appear from above the case, it's safe to swap to the flat-faced rammer. In this case, I probably should have shown you before I'd started charging it, but obviously the core comes to about there. So, right. So if you wouldn't want to accidentally hit it, so you'd mark the previous rammer so that once you saw that appear, you knew it was safe to use this one, and you'd also mark this one such that if that line was ever disappearing into the case, then you knew it wasn't safe to use that rammer. It's always useful to have a couple of safety checks built into your equipment. Okay, I think one more increment and we're probably good to swap over. Yep. Okay, so now we can go with a flat drift, flat rammer. Lots of different names that obviously have changed over the years. I know some people get very picky about what you call particular tools in this industry for historical reasons more than anything else. Historical accuracy is a big deal, particularly the ones that come from the traditional Italian families of fireworks, or Maltese, or they've all got their own nomenclature. Most of them make sense historically, a lot of them sound a bit strange. Such is the history. That's the great thing about working with pyro, is that you get to join that long history of people that have been twisting the dragon's tail for many years. It's something fundamental about humans, right? Control of fire. It must have been a big deal for us when we were running around scared of everything and saber-toothed cats were going to eat us, all that kind of stuff. It's just following the tradition, right? It's the whole Prometheus thing. We stole it from the gods, and here we are, controlling the universe, bending it to our will, one of the most powerful forces in nature, and short of nuclear explosives, chemical ones are terrifying, but they have that dual use nature that they can be used both for creation of beautiful things like fireworks, or for horrifying things like killing people. It's kind of like humans in general, and I think it has a beautiful symmetry to it. Alright, one more increment and I think we're done. Naughty me, I didn't cover it that time. Oh well. Back. We are done, so let's just screw the lid on that and get it the heck out of the way. Alright, so that's it, loaded. Taking it off, it's probably what some people would consider the most dangerous part. You have to grab and twist the thing. If it was going to explode, now would be the time that you might actually lose your fingers, but again, everything's a calculated risk. Done. One motor. Now, attaching it to a stick. I don't have the hot melt gun warmed up. Some people consider hot melt glue dangerous because I know some of the hot melt guns have been known to fail by spitting out sparks when they die. That's obviously a big problem in industry if you have a table full of product in front of you. Tape is always an option too. Gummed paper tapers, or using the old clove hitch knot was a traditional way of doing it. Got to be a little bit careful if you tie a clove hitch around a motor and you cinch it too tight. If you crack the grain, changes the surface area of the burning, and the device may explode if there's a crack in the grain when you first fire it up. So, attach the stick one way or another, and then fusing. So get a piece of black match, like so. I just fold the first little bit of it over into a little hook, and then I push that up into the motor. That'll have enough friction to actually hold it in the motor, as you can see. At this point though, the device is now a whole lot more dangerous because it's got this nice long tail of exposed black powder sticking out, so that if there's any sparks lying around, the thing can go off a lot more easily. So you probably don't want to do that until your very last step in your production. Alrighty, adding a payload to these things. I mean, they can't carry much, they're pretty small, but regardless of scale, it's the same for all devices. They all work pretty much, all rockets work pretty much the same way. You could obviously put a shell that had an internal burst charge and was to spread stars out. There's a universe of different things that you could put on top of it, but the most simple header that you can get is just really a bag. You could make it out of this kind of paper if you wanted. I always spread out paper when I'm working on it. So you can tape a little bit of paper around here to extend the nose of the rocket a little bit, and then you want to put a payload in there. These are D1 glitter stars. I made these many years ago and I still have some left. So you can see they were pumped with a syringe. I think this wasn't an insulin syringe. Actually, no, this might have been a straw. I might have made this out of a soda straw soda straw and some bamboo that I wrapped some tape around to get to the right size. And then they've been rolled in black powder to prime them so they ignite easily. They're quite small, they don't burn for very long. And actually for D1 glitter they're a bit small. It works better with chlorate colours because they've got a bigger flame envelope. D1 really works well in large comets, but these still look pretty cool. They're D1 glitter formula you'll find on my website and everywhere. I'm known as quite as an aficionado of it because for a long time it was the only thing that I had the chemicals to make. It's particularly popular because once you have aluminium powder, the only other thing that you need, apart from normal black powder ingredients, is sodium bicarbonate, which just about everyone has in their kitchen. So they're not the best glitter out there, but for the price and the simplicity, they're pretty good and it's reasonably safe. Aluminium, and as always, people worry about it taking off in alkaline conditions, which most certainly can, but the reality is if you dry them pretty quickly, you're fairly safe. Alrighty, so garniture-wise on these little guys, they probably carry 2, maybe 3 of these if you're lucky. So you make a little paper tube that extends the nose of the motor, and then you drop a few of these stars in it like so, and you just drop in the paper tube, and then you twist the paper tube closed on the nose. A little bit of loose propellant in the top helps break burst open the paper and shoot the stars out. I mean, there will be pressure in the motor, obviously, when the motor reaches this final bulkhead of black powder at the top. When it bursts, there'll be a bit of a release of pressure, and that should rupture the payload container if it's fairly flimsy anyway, but you do probably want to put a little bit of black powder in there just to scatter the stars out. Now, you'll only get a dump break, so it'll just shoot out the end and fall down towards the ground, but that can be quite effective. And realistically, come on, it's a bottle rocket. It's going to be fairly unimpressive no matter what you do, although for the simplest things are often the best, I think. Another thing you can do if you like bangs, I mean, everyone likes bangs, right? And that's one of the reasons you make fireworks in the first place, but I'm not a huge lover of the good old-fashioned salute, but if you want to, you can put a little bit of flash in the top, and then just a wad of paper is generally enough with most good flashes. Flash powder is obviously a whole other different level of danger, and if you're going to use flash, then I'll assume that you've read and suitably been terrified by all the warnings about it. Like all things, it's a calculated risk, and it does. The rocket whooshing up into the sky finished by a salute is a very traditional way to end a rocket, and I can't fault it. I've made plenty that have done that too in the past, but I must admit I like the more pyrogasm of pretty colours or something being shot out the end rather than the salute, but to each their own. Alrighty, have a safe and happy New Year's, and all the best for the next year, which is 2012. Wow, I must be getting old. Alrighty, see you later.